Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 28, 2025, about 2 days ago. The big claim is that grounding self-play reinforcement learning in a live document corpus lets a single model act as both a challenger and a reasoner, delivering average improvements of plus 8.9% on math benchmarks and plus 9.8% on general reasoning without human labels. The paper is titled, SPICE, Self-play in Corpus Environments Improves Reasoning. And, as we will see, the idea of asymmetry and external verification drives a surprisingly durable boost in reasoning. Alright, the introduction set up the need for grounded self-play. Figure 1 presents 2 bars charts that report accuracy across Math 500, AIM 25, GPQA Diamond, and MMLU Pro. The left panel shows ablations, where removing the corpus or fixing the challenger reduces scores, while the full method reaches about 78% on Math 500 and climbs across tasks. The right panel compares against R0 and Absolute 0, and the striped bars lead on every benchmark. So Figure 1 showed the gains. Figure 2 shows the end-to-end workflow that produces them. A single model alternates roles, creating an information asymmetry that keeps tasks challenging. The top row illustrates the challenger, which mines a raw document, forms a question and a gold answer, and earns more reward when the reasoner's accuracy has high variance. The bottom row highlights the reasoner, which answers without seeing the document and receives reward for correctness across multiple choice and freeform formats. Okay, the previous figure outlined the pipeline. Algorithm 1 now spells out the training loop step by step. The top challenger block shows document-grounded question generation, a penalty for invalid tasks, and a variance-based reward that targets about 50% success to keep difficulty on the frontier. The middle reasoner block answers without document access and gets a binary correctness reward. The bottom update block applies role-specific advantages with DRGRPO, so each role learns from its own signal. Alright, Algorithm 1 detailed the loop. Table 1 now reports head-to-head results across math and general reasoning. The table shows that the SPICE training wins for all 4 base model families, beating Strong Challenger, R0, and Absolute 0. Overall gains are about plus 9 for QN34B, plus 6 for QN38B, plus 11 for OctoThinker 3B, and plus 12 for OctoThinker 8B. The spread covers Math 500, AIM, GPQA Diamond, MMLU Pro, and more. So, after Table 1 compared training methods, Table 2 examines how corpus choice shifts gains. Natural reasoning lifts general reasoning most, with about 37 on average, while Nematron CC Math leads math with about 53. The combined corpus lands the strongest overall average at about 44.9, with math near 50.6 and general near 35. This pattern makes sense because each dataset targets different skills, so mixing them yields broader transfer. So Table 2 highlighted corpus effects. Figure 4 tracks training dynamics over steps. The full graphics show benchmark average rising as training proceeds, with blue lines consistently above gray. In Panel A, co-training the challenger lifts accuracy from about 35% to roughly 44%, while a fixed challenger plateaus near 39 to 40% because tasks stop getting harder. In Panel B, using a document corpus yields stronger gains than no corpus, reinforcing that external grounding sustains progress. So, while the previous figure tracked training dynamics, Table 4 compares challenger reward strategies head-to-head. The table shows that the variance reward used in SPICE delivers the highest scores, with math about 50.6, general about 35, and overall about 44.9. Absolute 0 and threshold trail at roughly 41 overall, and R0 reaches about 43.6. The takeaway is that targeting balanced success rates creates a curriculum at the frontier, which yields stronger learning than simply chasing failure or binary thresholds. So 2 takeaways stand out. Corpus-grounded self-play with challenger-reasoner asymmetry creates a durable frontier curriculum and avoids hallucination loops, and the method delivers broad gains without human labels, with co-training and the variance reward doing the heavy lifting. The broader implication is scalable, domain-transferable self-improvement from open corpora. That is it for the AI Research Roundup. I am Alex. Thanks for listening.